Hi friends, so let's do some analytics today. So let's see what we got. Today we are going to help ABC Data, a internet provider company which has been selling different plans to the customers, and we are going to help them with their sales. So let's take a look at the data first. So what we got is the sales data for the addresses, the different plans, and the advertising channels through which the sales occurred. So the plans that these people have been throwing onto the customer is 10, 40, 60, and unlimited ones. And the advertising channels are as here. So we got some about 7 to 8 different advertising channels through which these people have been uh, promoting their products. So, okay, let's see what we can do with this. So we are supposed to help the marketing. We can supposedly help the marketing on the campaigns, and then we can also help on the plans and the products. So this is the data for Australia. So let's take a look. So we start with this creating some functions in R. What we are going to do is the idea is to translate these addresses into the geo coordinates and then capture the data first of all, and then plot it on the map. So let's see what I have done is created two functions which returns their respective latitudes and longitudes for the specified address through the maps Google Maps API. And we start with, so the couple of things which we have started to do is on the data munging part. What we have accomplished is for the data. Let's take a look at the CSV. We have first of all, for each of the record, we have retrieved the longitudes and latitudes first of all, and then eliminated the uh, non-applicable or invalid records for which our function has not been able to retrieve the data. So this is because maybe there has been some typo because of which the API was not able to retrieve the data, as we can see in this for this record. And likewise, for now on, we will safely uh, exclude those columns from our analysis. So our final data set after the elimination, if you can see here, is about 1682 records and the unique plans and advertising channels. So let's just take a look at the data. So we have about 4 different plans that are being sold and 7 levels of different advertising channels. Okay, and next what we do is this is the function which kind of retrieves calls. This is the loop which calls the function and retrieves its longitudes and latitudes. And then we have the final data which kind of, after omitting our not applicable records, we retrieve this. Now once we are done with this, our data set has the cleaned data which we can work with. Now we're ready with the data. Now what we do is first of all plot them and see. So let's say first what we are going to do is we are going to work on the plan that the customers have purchased so far. So let's plot them on the map of Australia, and then take a look. So what we got here is the different plans of 10, 40, 60, and unlimited ones, and the different cities where each one of them were sold. We got Perth, Adelaide, Melbourne, ACT, Sydney, and Brisbane, where different plans were sold. But this gives you a high level and insight on where the sales occurred. Now let's also take a look at the different advertising channels and how each one of them occurred on the map. So let's take a look at that as well. And this gives you the advertising channels for the different locations. Let's move on. So this is so far we have not accomplished much. What we have done is simply just plotted all the sales on the map and shown it to you. So it's nothing great here. We started analysis now. Let's pick a city. Let's pick Melbourne. And what I'm going to do is for the latitudes and longitudes for Melbourne, I'm going to retrieve, let's say, 25 kilometers from the heart of the city, all the records from the entire data set. So what I'm going to fetch is essentially the Melbourne and suburbs data, and then work on them. So this is the code which kind of retrieves the data and puts it into a different data frame called mel data. And we got the Melbourne data here as of now. So if I may, these are all the Melbourne and suburbs records that I have. Now let's plot the Melbourne data as well, first of all, and take a look for the plans that have been sold in Melbourne. Okay, so there you go. So what you see here is for Melbourne, what are the different plans, and where are the locations for each one of them, where they were kind of sold. So each point here that we see are actually the customers and the locations which purchased these plans, and what were the preferences. So that's something that we see from the sales data. Next, let's try to take a look at the advertising data. So just to caution, these are all fictitious data. This is nothing to do with any real data. I've just kind of created them up. So there you go. These are all the advertising channels across Melbourne, and then the people who have used it. Now, so far we're good. Now let's see what we can do with this. So what we're going to do is we are going to help. We're going to work with the sales data on the plan. The idea would be to create a model based on the k nearest neighbor approach, algorithm approach, and what we are going to do is based on the current data, we are going to build a model which will predict for any incoming sales call. It is going to predict the kind of plan to help or to sell. So basically, if I make a call, the sales agent would know based on my geo coordinates, will be able to give me the right plan based on the people around me, the preference of the people around me. So let's say five people around me preferred, closest to me preferred an unlimited plan. So it makes sense for the sales folks to kind of pitch that plan to me, because birds of same feather flocks together. So maybe my social status, my finances are kind of same, because I stay in that locale. So with that kind of a presumption, we move on. This is a very uh, again, I would caution, this is a very fictitious data, so you might not get a very consistent results, but that would be the idea for me to build that model. And then I'm going to apply k nearest neighbor for my machine to learn on the data and then come up with the model to predict. So what I'm going to do here is I'm going to take the Melbourne data, and then I'm going to work on the k nearest neighbor for Melbourne. So the initial plan would be to just work on the plan, the longitude, and the latitudes. So these are the three important and the only attributes that I would be picking up from the existing Melbourne data. That is the data frame. So I work with them. Let's see. And then let's take a look at my kNN MEL. So I just got the different plans, the longitudes and the latitudes of the people who picked that plan. Now what I'm going to do is essentially what I have is, let's take a look at the number of records I have in my data set. So I have about a 191 record of sales for Melbourne. Uh, so out of them, I'm going to split my data set into train and test for building my model. So I create a new data frame which is called kNN train, and I create from the existing kNN Melbourne data. I pick records 1 to 170, and I pick the columns 2 and 3. 2 and 3 as nothing but the longitudes and the latitudes, and assign it to my train. I call it the kNN train. Likewise, I assign the test from 171 to 191 because I have got 191 records. So this would be my test data set, and then the target is nothing but my plan. So I want to be able to predict the plan that I want to determine. So and then the target test target. This is my test target for the existing records, and that's all. So now I'll be using the required class, and then I will be creating my model. So this is essentially the kNN code for the model. So it picks the training data set, the test data set, and the class of the target and the k value. So I have essentially the idea would be to get the square root of the number of records, and that value could be taken up as your k nearest. So let's go with the 13. A number, and then let's try to run the model. So we're ready with the model, and then this is this model is having your predictions. Now what we come up with the is the confusion matrix. So confusion matrix would be able to give us the predictions and the accuracy of the model against our test target, against the existing test target. Let me run this code and then explain it to you what it means like. So this is the output of the confusion matrix. What it says is this was the model, and these are the values that the model is about to predict, and these are the actual test data. So what you see here is the diagonals present the correctness of the model. So you can see two uh, records which my model had predicted for 10 GB at $29 were correct because the target also had 10 GB for $29. Similarly, one record for 40 GB at $59 was correct, and three for 60 GB at $69, and one was correct for 89. The rest of them on the other part of the matrix are actually the inaccurate or incorrect data. So you have seen that this model has one mistake on the 40 GB at 59, two here for 60, and two here for 40 as well. So all of these in a real world experience, what we would attempt is to bring a model which gives you all the zeros and only the diagonals to have the most of the efficient results. So the idea here would be to get the right k to be able to predict the better value. So essentially this should be that would determine your accuracy of the model. Now what I want to highlight here is, since the data is fictitious and I've kind of created them myself, there are a lot of inaccuracies, and hence you're getting a lot of incorrect predictions here, and the model is not able to run. But in ideal world scenario, you'll see a pattern and you'll be able to get better results out of it. Having said that, even though at the start of it you get some of the models, some of the predictions to be incorrect, the machine or the model will learn, which means that the incorrect record is fed into the training data set, and your model slowly but steadily kind of works up to a better score. That's how the machine learns. So that would be your accuracy improvement over a period of time, and then your model comes up with a better prediction. So far what we have seen is, with the simple data of the addresses of sales, we have been able to kind of come up with predictions. When the company's sales representatives approach a customer, they at least have an intuitive idea of which plan to predict, or which plan to pitch to the customer. It's not vague, and it's not absolutely irrelevant, or they are not giving the customer, they're not throwing all the choices to the customer, but they slightly have uh, an idea which plan to predict, which plan to approach to. Similarly, for the marketing folks, we could do the same thing on the advertising channels. Say a locality, a South Bank in Melbourne, prefers to go with the newspaper ads because most of the people use newspapers as the medium. So you kind of get a trend out of it, and you're able to focus on the right marketing promotion campaigns to enhance your sales. I hope kind of this video has added some sort of value uh, onto what we can achieve with these kind of analytics, and and it will definitely help you guys. Thank you for your time. If you really liked my video, please subscribe to my channel, and there will be more videos coming in soon. Thank you so much.